This is section 9.1, polar coordinates. To this point, you have graphed equations in the rectangular coordinate system. When air traffic controllers record the location of airplanes using distance and angles, they are using the polar coordinates or a polar plane. In a polar coordinate system, the origin is fixed at point O, or called the pole, and the polar axis is an initial ray from the pole, usually horizontal, directed towards the right. The location of point P in polar coordinate system identifies the polar coordinates that are in the form of r and theta, where r is the radius of the circle and theta is the measure of the angle from the x-axis. To graph a point given in polar coordinates, remember that a positive value of theta indicates it's going counterclockwise, while a negative value indicates that we're rotating clockwise. If r is positive, then P lies on the terminal side of theta, and if it's negative, it lies on the ray on the opposite side of the terminal side. So if we need to graph these values, if it's just on a regular XY rectangular coordinate plane, you would need to measure the angle, and then you would measure the distance out. So if we measure a 45-degree angle, it would be here. And then you would measure 2 units out. So if you measured this in inches or centimeters, we would say this is 2, and our angle is 45 degrees. Now for the next one, we're measuring an angle of 2 pi over 3, which 2 pi over 3, if we need to convert that to degrees, remember to convert from radians to degrees, you multiply by 180 over pi. So we can cancel the pi's. 3 goes into itself once, 3 goes into 180 60 times. So this would be equivalent to 120 degrees. So our angle would be here. So this is 120 degrees, but we're going a negative 1.5. So instead of going on the terminal side, we're going to go to the negative version of that. So we're going to start here, and we're going to go down negative 1.5 units. And for the last one, negative 30 degrees would be an angle that goes through here. So this is negative 30 degrees. So you measure it clockwise, and we would measure it with the length of 3 units. Now, once you are in polar grid, this is now a circular grid. We can now graph points on the polar. Now, each circle has a unit of 1, so this would be a radius of 1. This would be a radius of 2 because it's a second circle out, radius of 3, so on and so forth. So if we want to graph the point of 3 at 4 pi over 3, we're going to find the angle first, 4 pi over 3, and we're going to go out 1, 2, 3 circles, and this would be point P. 150 degrees, if you notice this polar coordinate is in radians, so if we convert this 150 degrees to radians first, remember to that you multiply by 180 over pi. So this is 150 pi over 180. If we reduce this, that's 15 pi over 18. 3 goes into both of those, so it would be 5 pi over 6. So 5 pi over 6 is on this line that goes through here, but it's a negative 3.5. So instead of being towards 5.6, we're going to go away from it. 1, 2, 3.5 units, and Q would lie over here. In a rectangular coordinate system, each point has a unique set of coordinates. This is also true in the polar coordinate system. You learn that a given angle has infinitely many, this is not true, in the polar coordinate system. There are infinitely many coterminal angles, so we can have multiple angles that actually locate us in the same place. So to find coterminal points, if it's in degrees, you're just going to take your R value would stay the same, and you're going to take your angle and add or subtract 360. If it's in radians, you can add or subtract 2 pi. Now, if we want to find one that has a negative R, you can add or subtract 180 or add or subtract pi. So we need to find 4 different pairs of coordinate points for point T. Now this is in degrees, and this is 1, 2, 3, 4th ring out. So T is located at 4 and 135 degrees. Now to get another point that falls between negative 360 and positive 360, I can do 135 and I can subtract 360. So our next value for T could be 4 and negative 225. So we have 2 different answers that fall between 360 and negative 360. Now you can also take your R value and you can make it negative. When you make it negative, you can add or subtract 180. So this would give me 315 degrees. Or we could have done negative 4, and I could have done 135 minus 180, which would give us our 4th point of negative 45 degrees. So if I graphed all 4 of these, they would all end up back at this exact same point. An equation expressed in terms of polar coordinates is called a polar equation. For example, r equals 2 sine of theta is a polar equation. A polar graph is a set of all points that has the coordinates of r and theta that satisfies the graph equation. Now, when you go to graph these, if they just tell you r equals some value, that's just going to be a circle that has the radius. If it tells you theta equals a value, that's just going to be a line that goes through that angle. So if we have r equals 2, we're just going to go to the second ring, and it would just be a circle that has a radius of 2. If we have theta is equal to pi over 6, you're just going to go to the angle of pi over 6, and you would draw a line that goes completely through that angle. So the red circle is the equation of r equals 2, and the green line is the equation of theta equals pi over 6. You can find the distance between 2 polar coordinates. To do this, you're going to use the following equation. Now you do need to make sure when you do this that your r1 and theta 1 comes from the same point and r2 and theta 2 come from the same point. So an air traffic controller is tracking 2 airplanes that are flying at the same altitude. The coordinates of the plane are A is at 5 and 310, and B is at 6 and 345 degrees, where the directed distance is measured in miles. First, we need to sketch this. So since these are in degrees, we can convert these to degrees first. 5 pi over 3 is 300 degrees. This is 315. The next one is 330, and then this is 345 and 360. So they tell us point A is at 5 and 310. Now 310 is going to be somewhere between 300 and 315. And we will go out 5 rings. So we're going to be about here for point A. Point B is at 6 and 345. So we would need to go out 1 more ring. So B would probably be over here. So our directed distance would be the distance between those 2 points. Now to find that distance, we're going to do r1 squared plus r2 squared minus 2 times r1 times r2 times the cosine of theta 2 minus theta 1. And remember, r 1 was 5, theta 1 was 310 degrees, R2 is 6, and theta 2 was 345 degrees. And if you put all of that into your calculator at once, you're going to get a distance of 3.44 miles. Now part B says, if regulations prohibit airplanes from passing within 3 miles of each other, are the airplanes in violation? So these are not in violation of the regulation since they are more than 3 miles apart.